All right. Welcome, everybody. How's everybody doing? Doing good? 4 o'clock session on the day 2 here at reInvent. Hope everybody's hanging in there. My name is Dan Jungst, and I work for Red Hat. I'm a technology evangelist for Red Hat. And with me today is Yuri Denisov from Scholastic. Scholastic is the world's largest children's book publisher. We're going to be talking a little bit about how a big enterprise like Scholastic can really innovate it and reinvent itself and run like a startup using OpenShift's, Red Hat's OpenShift Kubernetes platform running on Amazon's cloud. So hopefully that's what you guys are here for. We've got some great content. I'm going to talk for just a little bit, turn it over to Yuri, who really is going to tell the story that's important here. But first, I've got 2 favors to ask, if you'll indulge me for just a second. First is, we want to take the audience selfie. You ready, Yuri?
Yeah, let's do it.
All right. All right, everybody smile. Woo! All right, thank you. All right, that's the first camera special effect. The second one is, today is actually my wife's birthday. And I'm here in reInvent and not at home with her. So I was hoping that maybe I could ask you guys to say, "Happy birthday, Amy," on the count of 3. Would you guys do that for me? All right. Let me get the video rolling. All right.
Happy birthday.
Oh, shoot. Hang on. I had the camera going the wrong way. Let's do it one more time. That was good practice, though, right? All right. One more time. 1, 2.
Happy birthday, Amy.
Sweet. All right. Awesome. Thank you very much. So, enough silliness. Let's get down to it. As I said, I'm going to kind of kick this off a little bit. Let me just quick raise of hands. Who's familiar with OpenShift from Red Hat? All right. Pretty good percentage. So, OpenShift is Red Hat's enterprise Kubernetes application container platform. I'm going to dive into that in my section of the deck. But to start with, just kind of teaser slide, the marketing slide here is, the reason we're all here is because everything is moving so fast today. The business innovation is really all around us. Business models are changing, disruptions happening everywhere. It's like just super crazy what's happening today, right? With all things that you can do on the cloud and with containers and with AI and machine learning, it's just amazing. Every organization is changing itself. A couple of years ago, we used to talk about it was the Ubers and the Airbnbs that were disrupting things, right? But now every organization and every industry and every geography has the chance to do that, right, with these technologies that we're all working with today. It's super cool. Volkswagen has told us that there's over 10 million lines of code in every car today, right? So it's something that wouldn't be thought of 10 years ago or 15 years ago. Best Buy is really becoming a hybrid company. They have mobile applications for purchasing. They have brick and mortar stores. They have web e-commerce presence, right? So they've reinvented themselves to stay relevant in this hyper economy. So things like that are just super crazy. And there's newer and newer technologies that are coming out today. We heard Andy Jassy talk about a bunch of really cool new stuff that they're announcing. Amazon announces great stuff every year, right? How many new announcements will they have this year? But the things that are really impacting our day-to-day lives in enterprise IT and in startups and wherever you may work are these things like cloud-native application development, right? Being able to build applications and change them and innovate with them faster through cloud-native development approaches. AI and machine learning, really taking all the data that's out there that we're gathering and using it for a good purpose, right? Getting really neat answers out of it and then being able to serve your customers better. Analytics and Internet of Things, and it goes on and on. All of these things are really things that are allowing us to innovate faster and serve our customers better, which is ultimately what we want to do. We want to gain market share. We want to drive our business forward by helping our customers. So OpenShift is a way that we can deliver those kinds of applications, and it really supports a whole range of applications, from traditional stateful applications, cloud-native applications that are maybe stateless and microservices based, and then AI and ML and serverless and functions. All of this stuff can be run on OpenShift, our enterprise Kubernetes platform. It really contains a full DevOps tooling set for doing CICD. And it's all based on, of course, containers and stuff. One of the cool things about OpenShift is that it runs on Red Hat Enterprise Linux. You guys have probably heard about Red Hat Enterprise Linux. It's been around for about 20 years. that's important because RHEL, as we call it, or Red Hat Enterprise Linux, is certified on all the major cloud providers. It's certified on thousands of hardware vendors, and so basically it can run anywhere. And so because RHEL can run anywhere, OpenShift can run anywhere. So you can run OpenShift on edge devices, you can run it on bare metal in your data center, you can run it on virtualization, you can run it on Amazon if you want to, which is what we're going to be talking about today. So really kind of cool technology. Just to give you kind of an overview of what OpenShift is, we talk about it as enterprise Kubernetes, but it's actually Kubernetes plus. It's more than Kubernetes. And we take the upstream Kubernetes technology, which we've been working with for about 5 years. So we got on Kubernetes very early, decided to move OpenShift to it from the Kubernetes 1.0 days, and we've been investing in the upstream project and putting a lot of code into that, and I'll talk about that in a little bit, but we are the #2 contributor to Kubernetes behind Google. And so we've implemented things that enterprises need, like role-based access control. When we started, Kubernetes didn't have any role-based access control. And they were like, oh, no, you'll just deploy another cluster if you want to give a different team access, right? And we were like, no, enterprises probably want role-based access control. So we built it and checked it in and gave it to the community. So it's Kubernetes at the foundation, Kubernetes that we've made sort of enterprise grade, but it's also got what we call productive abstractions on top of that, things to help operations teams manage and run Kubernetes much more easily, things to help developers build and run application code very easily and move to kind of a DevOps approach. So these are things that we've added to Kubernetes and that we've packaged up and we offer as OpenShift. For the operations teams, we've worked really hard in making it really easy to install and manage OpenShift from a day 2 and ongoing standpoint. So a couple years ago, we bought this company CoreOS, which was also in the kind of Kubernetes and Linux space. They had done some really cool stuff around automation for Kubernetes, and so we've incorporated that into something that we call OpenShift operators. It's actually part of the upstream as well, Kubernetes operators, but we've really integrated operators very deeply into our OpenShift platform so that OpenShift basically can manage itself through OpenShift operators. If you don't know about operators, come by our booth and we can talk to you about them. But they're a way that you use Kubernetes constructs to be able to automate things that need to happen. So, for example, you may have an operator for a database. The operator knows how to run the database, how to spin it up, how to take it down, how to back it up, or whatever, and it tells the operator then has the Kubernetes CRDs and constructs to be able to tell Kubernetes what to do with that. Well, we've done that for running Kubernetes itself. So you can have an automatic installation of Kubernetes. To install OpenShift on AWS, it's really just a push-button, single-click installation. Get a full cluster up in like 15 minutes. Because of this automation technology, we can also have auto-scaling. So the OpenShift cluster, the nodes that are underneath Kubernetes, will scale out automatically on demand. We also have over-the-air updates. So if you're running an OpenShift 4 cluster, it can be given an update which over the air, which then it will apply to the cluster itself, and without having to take the cluster down, you can have things upgraded. A lot of other operational capabilities like monitoring and chargeback and a pluggable architecture, things like that. But again, we worked really hard to make it easy to use Kubernetes in this OpenShift platform. And then for the developers, probably the most important constituent is the developers, right? They are the kingmakers today, and because it's them that are going to build those applications that are going to drive the innovation, that are going to make your customers happier, that are going to get more revenue and more market share for your organization. And so we've worked really hard to add developer capabilities and developer productivity tooling into OpenShift. So it's got CICD tooling built into it. It's got a browser-based IDE that actually runs on OpenShift, and it's a collaborative IDE, so teams can work together writing the code, and it's all just done in the browser, so a very elegant solution. It's got self-serving service provisioning for the developers, so they can get access to what the resources they need, right? They just say, I need a new container with Node.js in it, and I need another container with Mongo, and boom, they're there. So it's got a lot of, again, these features and capabilities that are designed to make life easier for the developers so that they can write applications, get the code built and deployed and tested and scanned and security scanned and everything else needs to happen in the CICD pipeline. OpenShift 4 is our latest release. We're on 4.2 now, but it's, as we call it, a smarter Kubernetes platform. And this gets to where I was talking about the automated installation, the operators, kind of seamless deployment, the auto-scaling, the one-click updates. All of this is really, again, designed to make day 2 management of Kubernetes easier, right? It's okay just to get Kubernetes up and running or get OpenShift up and running, but then somebody's got to manage it on an ongoing basis, right? And so we're investing in that, making that operator's job easier. So let's talk a little bit about how we do software development at Red Hat. So we have an enterprise open source development model. What we do is we work in the upstream open source projects, and then we build enterprise products from those, right? So we may pull 10 to 12 different projects into OpenShift and put them together and then test them and then release our productized version. Along the way, we actually find a lot of bugs. So when the upstream open source community says, oh yes, Kubernetes 1.0 is ready, then we pull it down and we test it, and we often find bugs and CVE, security problems, that kind of stuff. So we patch all those and fix those, and that goes into our release, but we also give that back to the upstream. So we have a lot of integrations, certified partners. We have a 9-year kind of lifecycle management for OpenShift in terms of support capability. And again, we've been one of the leading leading Kubernetes contributors to the open source project. So this is sort of the Red Hat's business model. We take the innovation that's coming out of open source, but we make it consumable by the enterprise. There was an interesting IDC report that was done recently about running OpenShift on AWS in particular. And they talked to a bunch of our customers and found some really incredible ROI, like 661% ROI for running OpenShift on AWS. One of the neat numbers that came out of it was that the companies that were doing this on average were generating more revenue than they were before, so $32 million more revenue. These are just a couple of quotes from that report. The report is linked here. We can also get it to you if you want to come by our booth in the expo hall over at the Venetian. But these customers are really seeing an increase in productivity levels that's just kind of crazy, right? 60 to 70% increase, and driving more revenue, 15% more revenue, worth tens of millions of dollars, just by using this platform to build their applications, run them, deploy them, and serve their customers with them. So with that, I'm going to turn over to Yuri. He's going to tell us about a Scholastic's adventure with OpenShift, and after that, we'll take happy to take any questions at the end.
All right, thanks, Dan. So today, I'll be talking about Scholastic's journey with containers, microservices on OpenShift. So just to set the background, Scholastic's one of the largest children's book publisher companies out there. So we have presence all over the world, but we're mainly based out of New York City. It actually might be surprising to some of you, but we actually have a pretty large tech department, and we do try to work with the latest technologies out there. In fact, we actually started our AWS cloud migration journey back in 2012, and now we're like 90 to 95% on cloud. So before I get into OpenShift and why we chose it as our Kubernetes platform, let's talk about some of the challenges we were facing back then. So around the time of 2016, we had just hundreds of monolithic applications deployed. And by now, most of us know, the negatives of all the monolithic architecture from an application standpoint. There's actually a lot of overhead from the infrastructure side of it as well. So for us, this mainly involved us having inconsistent infrastructure practices. And what I really mean by this is that we had some teams that were actually building out servers using automation tools like Terraform, Chef, to build and configure, but then they would go in and update things manually and break the automation. Other teams were just completely building everything out manually, like in the UI in the AWS console. We faced similar issues with monitoring and alerting. So we had teams using just their own various stacks of tools, whether it was like New Relic, Sensu, Apica, Prometheus, whatever. There was just no standardization across the board. So this wasn't that bad, but it wasn't great either. So lastly, the biggest challenge for us was our application time to market to go live in production was about up to 2 to 3 months, and that really depended on the size of the application. This was mainly due to how our deployment process worked back then. So when developers were ready to go to dev environment or QA environment, they had to wait for their infrastructure to first be built out. Then the operations team would do the deployments. You can imagine this takes pretty long. We also have a process at Scholastic which we call operational readiness, and this really involves the application teams sitting down with the operations team and going over their application architecture and really making sure all the alerting and monitoring is in place before they get to production. And this process was taking up to 2 weeks back then, mainly due to all the back and forth. So we knew we wanted to use microservices and Kubernetes, but before we decided which Kubernetes platform to go with, we had some goals in mind. For one, of course, we wanted to move away from this old monolithic architecture. And really our idea here was to densely pack our AWS EC2 nodes with as many containers as possible, and then we'd just be able to scale as needed. Of course, we wanted to reduce time to market. 2 to 3 months is very long, and we really thought we can do this by just maybe simplifying the whole deployment process. Another huge one is we wanted to really gain consistency across CICD pipelines. Back then, we had a few teams that were actually running proper CI automation for their CI builds and proper code testing, but not everyone was doing it this way. On top of that, we really had no insight into whether teams were running proper unit code test coverage. So our idea was really to create these pipelines and force developers to run proper tests before they can deploy their code. Lastly, we just wanted like a simple Kubernetes platform that we can deploy out of the box with ease. So why did we go with OpenShift? Well, there was a few features we really liked that stood out to us. But before that, I do want to mention that we did try to spin up vanilla Kubernetes, and we found like it was still in its infancy back then. So there was just a lot of overhead bits and pieces to manage. It was difficult to install. And mind you, this is before like managed services like EKS existed. We also tried Tectonic. So we found that was actually pretty cool because their one-click installation was impressive. But by that time, we were already doing a lot of development work with OpenShift, so we kind of settled on it. Now, what OpenShift had was a source-to-image, S2I. And we really liked this because we thought we can just standardize the base image for all our applications, like all our microservices. We could just basically choose whatever packages we wanted to install in this base image and then provide it out to developers to build their apps with it. Then there was also routes. This is an interesting one as well. So we saw OpenShift had routers that acted essentially as like ingress controllers. And this came out of the box. So it was really easy to get it up and running and with no issues. Next thing is OpenShift templates. They're similar to like Customize right now with Kubernetes or maybe like Helm, except they're native to OpenShift. So we thought we can really utilize them to build our CI/CD pipelines around them and with them. And lastly, we felt that the user interface, like the web UI console of OpenShift, was just a little bit more developer-friendly versus like the vanilla Kubernetes dashboard, which requires a little bit more expertise to navigate. Now, we actually went with the supported model of OpenShift, so the enterprise. I do want to mention that we actually did try to spin up OpenShift origin clusters, meaning the open source version at first. But back then, actually, the cluster went down. We had issues with like the certificates for the registry and the etcd, and we just didn't have enough like experience and knowledge to fix it back then, so we went with the supported model. Now, we deployed everything on AWS, and this was an obvious decision for us since, as I mentioned earlier, we were already on working with AWS and Amazon since 2012, and we had like 80% of our infrastructure there at that time. So we just deployed OpenShift there as well. And the best part was we were able to really use our existing public and private route 53 domains to really manage all the routing for OpenShift for us. And having wildcards made it that much simpler. All right, now I'll talk a little bit about how we set up the infrastructure for OpenShift. So we started off by working with a Red Hat engineer to get the first cluster up. And after that, we were actually able to build out all the other clusters ourselves. Red Hat originally provided all the necessary playbooks, so it was simple enough to get the other clusters going. We actually use the OpenShift Ansible contrib playbooks from Red Hat on GitHub. And what they did is really just spin up the infrastructure and then install OpenShift on it. Now, we actually ran into some problems when it came time to upgrade. So the recommended method was to spin up a new cluster with the new version and then migrate all your workloads there. When we tried to do this, we found out that these playbooks had actually been deprecated. So we had to do a little bit of reverse engineering and going in and updating the playbooks with the new package versions for the new version of OpenShift. And then we were able to really spin up the cluster. We had some more issues with the migration in terms of our DNS strategy, but I'll get into that in just a little bit. So as I mentioned, we were using these OpenShift Ansible contrib playbooks. And what they were really doing is there was a Python script that would launch a CloudFormation, spin up the infrastructure, and then it used Ansible to install OpenShift on it. Now, the odd part is we actually didn't have to use an Ansible host file here, meaning this really limited our ability to customize our OpenShift installation options, which is usually done using the Ansible host file. Now, the way around this was we were still able to run some of the other playbooks after spinning up the cluster, like installing OpenShift, fluent delogging. But what we also did is really we wrote some of our own playbooks to do things like set up Sensu or set up LDAP. And then we kind of packaged them together and created sort of a Postbootstrap playbook for our clusters. So we'd run that after we spin up a new cluster. So here's our basic architecture in production right now. So originally, we went with the recommended high availability setup of having 3 master nodes, 3 infrastructure nodes, and 3 application nodes, and then scaled from there. For the master nodes, we actually used, and the infrastructure nodes, we used the recommended size, which was M4 extra large, I believe. Now, for the application nodes, we actually realized we had more memory-intensive microservices running on mainly Spring Boot APIs rather than CPU-intensive. So to really optimize for this, we used the R4 double XL size for the application nodes. Now, this setup of 3 masters and 3 infra nodes was fine for our non-prod clusters. However, for production, we decided to scale up our infrastructure nodes to 5 to add some resiliency to the routers. What we noticed was these infra nodes, they were running some very CPU-intensive pods like Prometheus and Telegraph. So we really didn't want to risk any downtime and outages, and we scaled up as a precaution. In terms of the application nodes, really here, we just scaled horizontally as our usage went up. All right, I'll switch gears a little bit, and now I'll talk about how we implemented our CICD pipelines on OpenShift. So we actually went through 3 versions of our CICD pipelines. And really, the biggest challenge here was getting developers on board with this new deployment process. This is really where having source to image and templates came in very handy for us. So what we essentially did for our first 2 sets of pipelines, we were just taking these basic OC commands and then wrapping them in various Jenkins jobs. And then developers would run those to build their resources. And essentially what's happening here is we were passing environment variables to these templates and then processing them to create all the necessary resources like your build configs, your deployment, service, routes, and so on. Now, during these first 2 sets of pipelines, we actually did not give developers any UI access to OpenShift. So really, they were limited to the Jenkins jobs. But we were packaging like the New Relic jar with every deployment, and then we were sending all our logs to Sumo Logic. So developers were still able to get all their application metrics and logs externally. Now, this still proved to be pretty difficult in onboarding new teams since they had to really memorize the order of these jobs, how to run them, and debugging was difficult for them. So after a lot of feedback, we decided to create a new 3rd set of pipelines. So for our 3rd set of pipelines, we finally utilized the built-in OpenShift pipeline view with the integrated Jenkins in the back end. And what we did here is really just pack all those previous jobs into 2 final pipelines. So the first one was just a single build pipeline that developers ran once per environment, per app. What it did is really just create all the resources like your deployment, your service, and your route in each environment. The second one was a true CI/CD pipeline. This, and you can see an example right here, this was actually triggered by git commit webhooks, which then started the S2I build. Now the image build started, and this was actually hooked into SonarQube. So now we could see whether the developers are running proper unit code tests in our Sonar Cube, and we can have metrics on that. Once these tests passed, their image was built and then deployed to the dev environment, as well as uploaded to our external registry in Artifactory. Now, developers could go and verify functionality, and then they could go and deploy to other environments, like QA, perf, so on. And this was really done just by patching the image version and the deployment. For production, they actually needed a token from the operations team, and then they would be able to deploy. So it might sound simple, or this whole process, I don't know, but we actually ran into some pain points and have some lessons learned along the way. One thing was we ended up with some huge image sizes. So we had images that were like a gig and a half, and this meant it was taking like forever to download them from the registry. Of course, the solution is to really use smaller base images, maybe a different standard base image, try to pack as little as possible and keep your images as minimal as possible, and that's something we're still honestly working on. Now, during our first wave of migrations to OpenShift, we actually deployed some PHP applications that we try to containerize. And what happened was, once some of the pods started going down, they were taking like very long to come back up, and then this created a cascading effect and caused an outage. So what was happening inside these containers is really they were running like a bunch of bash scripts, checking out Git repos, running some extra commands. So meaning this would take forever for the application to become alive and healthy. Now, of course, we know this is not the best practice, but that's something we really learned along the way with experience. So this really brings me to my next point, and it's just make sure you add resource limits to all your deployments and your pods so they don't really go rogue and just take over all the resources from your clusters. In this case of these PHP applications, we were really able to quickly go in, add memory, add CPU limits to these pods, and really limit the blast radius just to their namespace, and the rest of the cluster was left working fine. Now, as I mentioned earlier, we didn't really have a proper DNS strategy when it came to time to migrate our clusters and workloads. So what happened here is, for our first set of clusters we built out, we actually used the cluster name in our domain. So something like star.apps.clustername.scholastic.com or whatever. Now, of course, when we spun up new clusters, new cluster name. So it was actually a lot of work and coordination to go back and ask developers to update all their API gateways, all their integrations with the new URLs and the new routes for their applications. So to really solve this for future migrations, what we did is we created a more generic domain, something like star.apps.scholastic.com, whatever. And now we were able to really use Route 53 to delegate the environments by pointing to the ALBs of each respective cluster. So this made the next migration much simpler, because now we ran the same pod in two clusters with the same route, the same URL, and we could control the traffic from the Route 53 entry. Another thing I'd say, just as a general suggestion, is just be open to using custom tools when needed. In our case, before Prometheus was integrated into OpenShift, we actually used a custom Prometheus and Grafana solution for us for like alerting and monitoring, and it worked out great. We also built out a custom FluentD forwarder pod that we used on top of the existing OpenShift logging solution to really just filter out and just send logs to Sumo Logic. So to kind of wrap it up, we had some very positive results with going with OpenShift as our Kubernetes platform. For one, we had standardized the deployment process for developers. Now, whether the application was a Spring Boot app or maybe Node.js, Python, the deployment process was almost identical. No more PHP apps, though. So we actually reduced deployments down to a few minutes as well. As I mentioned, now they're kicked off via Git commit webhooks. So the deployments are quick. The infrastructure is already up there. Developers can log in the cluster, go and do the deployments. They don't need to wait for the new servers to be really built out for them. Now, this also changed how operations worked for us. Our OpenShift infrastructure was really now sanctioned by the operations team, meaning we had all the proper monitoring and alerting in place, using tools like Prometheus, Grafana, Sumo Logic. We used Sensu and even CloudWatch alerts. So now when developers, they're ready to go to production for an application, they just hop on a quick call with the operations team, and they really go over all the bits and pieces of their app architecture, aside from OpenShift, since that's already sanctioned. And this really reduced to a simple call down to maybe an hour or so. So here's an example view of what our developers see today. Basically, each team or business unit really has their own CICD namespace. So from here, they're able to deploy into any other environment. Of course, the big difference is now they get UI, they get to access, they can log in the OpenShift console. They're able to go in, update their environment variables, debug and monitor their applications as well. And of course, we're still packaging the New Relic jar with each deployment, and we still send logs to Sumo Logic, so that's available externally as well. Now that developers are really able to deploy, test, and monitor their own applications, this really gives our team more time and cycles to go and really work on new things and updates instead of going back and forth and supporting the developers. So another very huge benefit we got with OpenShift, and you get this really with Kubernetes out the box anyways, is resiliency. So just last Labor Day, AWS had an outage in, I think, one of their US East 1 regions. And we actually had a production node go down during our peak back-to-school season, meaning this is when the most kids are logging into our services. So as we know what happens with Kubernetes, these pods were just, they migrated and were distributed across all the other application nodes. So even though this production app node went down permanently, we faced really no outages from the OpenShift side at all. Another result we had, or really big benefit, was that we took for granted, actually, that I think about it, is OpenShift allowed us to really natively plug into our LDAP. And what we did here is create AD groups, Active Directory groups, and then we mapped them to the respective namespaces. So now the application team, like the owners, were able to manage access to their own namespaces. And this kind of took our team out of it, meaning less time for them, waiting time. And probably last and the most marketable thing out of all of these results is we reduced our time to market to around 2 weeks now. As I mentioned, all the infrastructure is already up. OpenShift is up and ready for them. All the environments are there. Developers just can now log in and go and deploy their code. And once they're ready, they can go to production when operations approves. Right now, we have over 200 microservices running in production on OpenShift and AWS, and that number is really growing quickly. We really started off with trying to deploy some microservices that were broken off of old monolithic apps, but these days we're really trying to build out more small and nimble microservices. The majority of the microservices we have right now are just Spring Boot API backends. But we do have a lot of other apps, so some front-end Node.js apps, and some Python games, such as Uka Island. We even have an app in production that's consists of 15 microservices, I believe. So we're really trying to just embrace this whole microservices model right now at the company. So what's Scholastic doing next, you may ask? Well, we're actually in the process right now of upgrading and migrating to OpenShift 4 on AWS. So we spun up the clusters. It's pretty interesting now. It's impressive with their new operator-based installation. We see it has a lot of new features that Tectonic had before, like being able to really upgrade your cluster on the go, Kubernetes and your cluster. So I think this is pretty huge for us. It'll save us time because we won't have to rebuild new clusters each time now. We could just click the button, then let operators do their thing and really update themselves and the cluster. Next project we also have is we're rebuilding our 4th version of CICD pipelines. And this time we're going to be using Helm along with the still the native built-in pipeline view with the Jenkins and OpenShift. And we're really doing this to kind of align closer to the Kubernetes community, and Helm is kind of the standard. On top of that, Helm 3 was just released, so that really takes out all the security issues that were there with Tiller before. We're also looking into trying out some service mesh tools, which is, big buzzword these days. But Istio is now integrated with OpenShift, so it's something we want to try out, and it's definitely on our roadmap. And I guess lastly, we just constantly look out for new and cool open source projects, and we just always experiment with them. So we'll continue to do that and just POC them. And yeah, that's pretty much it. If you guys want to know more about OpenShift on AWS, just check out these links here. And me and Dan will be happy to take any questions if you have any. Thank you.
Thank you, Aaron.